Alright, so we have a different one today. We're not working on Fresh on Body today. Well, this one is geared back for world builders. Yeah, my first video was a G-plates one, and that's the only one that has gotten much traction, so... Here, this is going to be a lesson on Rebound. Of course, I'll teach you the Python API, since, you know, most people know here, if they... in the world building community, if they even know programming at all, it's probably just Python. There is a C API, and I do use it, but like, no one here is learning C, so I'm not gonna deal with that. Anyway, I'm just gonna make a ven real quick, so. Okay, now finally I see the .ven thing, which is correct. Verify here. Which Python? Okay, good. That Python. Amazing. Okay, now that this is basically complete, I can actually code some stuff. Nvim. Okay, we'll just... So first we need to install it. It's basically as simple as pip install Rebound. Just so you know, you don't need a virtual environment. I just do this out of habit. You can't just use your global thing. Use your global Python. Okay, cool. So now that this is complete now, installing Rebound. Hopefully you're not stupid. And are not scared of the command line. And I won't assume you have programming knowledge here because, yeah. Because I have to, apparently. And also because people... But anyway, let's just continue on. Let's create a script. You could call it anything really, but it just has to end in a .py extension. You could use VS Code, Vim, Nano, whatever you want, PyCharm, unnecessary. Okay, but PyCharm does give you the option of a run button, which means after you're done writing it, you can just press it and it should work. But like, yeah, that's not great. I mean, that is great, but like, it's not controlled, and it doesn't really matter, does it? Anyway, nvim app.py, I'm just gonna do that. I'm just using NeoVim for this job. Yo, should I use Vim for this? Should I? Yeah, let's just use NeoVim. Anyways, okay, so step 1, you have to import Rebound. This is a very important line, because if you don't, you won't get Rebound. You won't at all. If you want, you can do like as and then whatever you want your alias name to be, but I'm just gonna do this. Now you can create a sim by doing rebound.simulation. Okay, yeah, this is amazing now. Amazing. We can obtain, if you want to shorten this, you can use rebound as reb, and now you can just do reb.simulation. This is an alias. So I'm just gonna type in Rebound here. Okay, cool. Next, I have now you can sim.add. This is a special function. This line here creates a simulation. You can name this anything you want. You could call it like simh simulation. Bruh, as long as you can't do this though. And it can't be a reserved keyword in Python like import or as. If you need to have multiple words, you can't just use an underscore. So I'm just gonna use sim. Simple enough. Okay, now here, simulation here, there are no like units, like explicit units that it stores or anything. Actually, at least as CPI. In this Python API, which we're using right now, you can do sim.units equals like kilometers, seconds, and oh yeah, and kilograms. For example, just to list them, just put it in double parentheses like this, and then put in three units. As long as they're one of them is distance, one of them is time, and one of them is mass, and they're comma separated, you're good. Okay, so now, like, say by default it uses astronomical units, aka solar masses, astronomical units. Well, the second astronomical units I just said meant an AU, or 1 Earth radius. I assume at this point you read that enough to have that ingrained. And kilogram, and not kilogram, sorry. Oh yeah, and time in years, in Julian years, aka 365.25 days. So it by default uses that. I'm just gonna respect that idea here. So mass equals 1. You could also, I think you could also set a variable. Give each. You can't really wait. Not like this. You could access the particle by the sim.particles. You could do sim.particles index like 0. This is 0 based indexing. So 0 is the first particle. 1 is the second. 2 is the third, and so on. If you need to, you could use this feature to like give your particles a name, like sun or something. But why would you do that? I mean, that's pretty useful, but at least in this case, it's not. So, sim dot add. You could add multiple of these, like here. You could do one. You could do it scientific notation like this, normal. Okay, now we do need to introduce. You can also set a location by saying x equals, I don't know, like 1, y equals 1, z equals 1, vx equals 1, not 1, but something like. Yeah, you could just set x, y, z and vx, y, vz like this. If you've already used exoplasm, this is going to be simple. So, yeah. But if you need to add something in an orbit, the recommended thing to use is the orbit API. The orbit API is everything at sim.add, except you add a primary, so 0, 1 say. Let's say you set it a equal to 1. If you need to, a primary can be given by just giving a particle that it's a primary to. So in this case, I assume it's the sun. So the first one. Okay, beautiful. You can add in the orbital parameters. So E equals 0, inclination equals 0. Yeah, inclination, just the inclinations though are in radians. So if you need to, you could use math. You could either use the math or NumPy modules and install. In the case of NumPy though, you do need to install it by using pip install. So I should probably just show you the math. Math.radians just allows you to convert from degrees to radians. Yeah, and NumPy has a similar function. Yeah, but for 0 it doesn't matter, does it? You could set mean anomaly, and lowercase and capital omega for argument of periapsis and longitude of ascending node respectively. So yeah, okay, this is good. Yeah, but I think you're gonna be doing AL. This is very useful. Okay, so now say you're done setting up your simulation. How do you integrate it? Simple, the integrate method. Integrate and the amount of time you want to integrate it for. So in this case, it's about a year. So let's integrate this for about a year. Oh yeah, each particle, and if you want to know where it is, you could use like print. Print is a basic function in Python to print stuff. Oh yeah, and you can just do basic math operations. No need, you can do basic math operations, nothing complicated. Print, you could use print to print things, so say you wanted to print the second one, so let's do sim.particles. Well, it's gonna be easier if I make a particle for the planet, or rather variable. So planet equals sim.particles index 1. And now you can do planet.x planet.xyz and planet.vxyz. You can also do these individually. So now if you run these, oh, you cannot do that? Oh well, I mean, if you can't do that, you can still always just run these directly. like, say you want to know where it is now. Let's just... I'm gonna quit this now, and now I'm just gonna run Python now. Python 3 app.py. And it prints stuff. Amazing. The timing is going to be in... The units are all dependent on whatever you put in for G. So by default, it uses solar units. So it's solar mass, AU, and years, Julian years. If you want, yeah, you could get math. You could get pi by importing math and doing math.py. Or you could do from where you do from math, import pi. That's also an acceptable thing to do. So now if you run this, yeah, now it's actually a year, because units, it's going to be 1/2 pi times. Remember the time, the period is actually 2 pi times. Has a 2 pi factor, so you have to multiply by 2 pi to get back your full orbit. Yeah, just so you know, if your IDE complains, don't worry. Yeah, it just doesn't understand this stuff. It's like, it thinks it's a list, and so the property doesn't exist, but yeah, it actually does, and the Python runtime won't care. Yeah, Pylance hates this especially. If you run this directly, yeah, this also works. Though it does make it look a bit better. Okay, nice. So now you have a system. So now you can integrate stuff, but how will you know if your thing actually worked? Like if it's stable or not? Well, simple. If you're smart enough, you think you could do you could do subtraction logic, or you could use matplotlib to do your job. Or you could write the whole thing to a document or something and make someone else do this. Okay, so now, so this is going to be the part where you're going to have to learn some basic stuff. You have multiple options for, writing this to a file. Sorry, not writing to a file. You have multiple options to interpret this. One option here would be to write to a file and then get some third-party program to interpret it, like you do with orb and Excel. Or you could do it in Python with matplotlib. That's a second choice. Let's just say you wanted to investigate with matplotlib. Yes, I'm just going to put that to the end. So, first of all here, let's just say we want to write to a file so we could write it down. So, first of all, let's just import dumpy. Actually, that's unnecessary. Yeah, we could just add one. We could just add like a CSV. Okay, yeah, so this is most definitely for programmers and researchers. Because if you don't know any Python, you're going to have to struggle with interpreting data. And so as to check if your system is not failing miserably. So yeah, I think I'm just going to cut the video here. Bye.